Okay, so this is the work that I sent home for just trying. So let's look at this first one. This is a balance. So it means that there's a whole rectangle on one side, and that's equal to half a rectangle and a star. So a whole rectangle is equal to half of a rectangle and a star. If half of a rectangle and a star is equal to one whole rectangle, let's just imagine that this half a rectangle is this half right here. So we're left that with a star is equal to the other half of the rectangle. Well, I think the rectangle halves are probably even. So the star is equal to half of a rectangle. So another way of saying it is 2 stars is equal to a whole rectangle. And then we're given that 1 star is equal to 3 pounds. So this star is 3 pounds and this star is 3 pounds. So then the rectangle must be 3 plus 3 or 6 pounds. So then the question, when we actually get to what the question is asking, how many is 3 whole rectangles? Well, we know that 1 rectangle is 6, so we can just put in 6, 6, and 6. 6 plus 6 plus 6 is 18 pounds. Okay, so even if you don't understand all of this, you can get there however you can. All right, some people might have looked at this and said, well, if half of a rectangle and a star is a whole rectangle, then I know a star is half. So I can just say that, this is 3 and this is another 3. So this must be 6. And so then I can label it down here. There's many different ways to get to the answer. And it doesn't matter how you get there. If you don't know how to do multiplication 3 times 6, then you can just add 6 3 times to get the number of the pounds that is equal to 3 rectangles. Okay, let's look at this next one. 36 times 2 is equal to 48 plus a question mark. A question mark means like a blank. What is it equal to? So we have to try to figure that out. We could do one side of the equal sign first. So 36 times 2, well, I'm just going to add that because 36 times 2 is 36 twice. And maybe I don't like multiplication, so I'm going to add it instead. I get 72. So I can replace this 36 times 2 with a 72, and I'm going to keep the rest of it the same, is equal to 48 plus something. So how am I going to get this something? Well, I need to take 48 away from 72 to find out what's left. This is just like you probably had some fact families. Gabriel's been doing fact families. He's not real happy about it. But maybe I have 3 plus 8 is equal to 11. Another way of writing this would be 8 plus 3 is equal to 11. And then if I want to write the subtraction facts that go with this, I would say 11 minus 8 equals 3, and 11 minus 3 equals 8. So I have 48 plus something equals 72. If I look at my fact families, let's imagine that this is maybe my 48, and this is my something, and this is my big number of 72. I can rearrange that into a subtraction problem. So I start with the big number is 72, and then minus the one that I know, which is 48, and that's equal to my box that I don't know. So I can take this addition problem where I'm missing something and rewrite it as a subtraction problem where the answer is what I'm missing. So now I just have to do 72 minus 48. And I'm going to have to borrow. And I get 24. So I know that 24 is what I can add to 48 to get the same thing as 36 times 2. If we look at the next one, it's actually the same type of problem. It's something times something is equal to something plus something that we got to figure out. This time, though, instead of putting a question mark or a box, they put an X in and they say find X. Well, X is just something we don't know. You can use any letter to stand for it. So it's just something we don't know. So we're just trying to find out what number will go in this spot. So again, you can just imagine it as a box that you have to figure out what goes in that box. Now this one, the last one, I said, oh, well, we can just do it with addition. You could do repeated addition here if you add 7,124 5 times, or we can come over and actually do 7,124 times 5. And we get 35,620. Now that is equal to 32,481 plus something that we got to figure out. Well, just like last time, we went with the addition problem with a blank term or addend in it, and the answer turned into a subtraction problem. So that's the same thing here. I'm going to take the biggest number, that's the total, and I'm going to subtract what I already know to find out what I don't know. So 35,620 minus the 32,481. And I get 3,139. So x is equal to 3,139. It asked me to find x. X is what's going to go right here where I didn't know. And so if I put 3,139 in and add it to the 32,481, I will get what 7,124 times 5 is. It's the same thing. Okay, so this looks like an algebra problem, and it is. It's what kids in algebra in 8th or 9th grade are doing. But we already know how to do these things. We just have to remember, how do we find them out? What can we relate to a little problem that we know to make it into this big problem that we don't understand how to do? So sometimes if you break it up into something that you already know and say, well, how does that apply to what this looks like? It was really nice that we started with this smaller problem. So then this bigger one that we might have just said, oh, that's too many numbers, I don't even know. We can look at it and go, well, it's the same thing that we just did with these smaller numbers. They're just bigger. So don't let the big number scare you. Let's skip down to the big number right here. It says round this huge number to the nearest billion. Now there is one thing we have to know. We do need to know what place value the billion is in. Let's see if we can figure it out. I know that down here, I'm going to call it my units. So it's units, tens, and hundreds. Now, when I get to the next one, it's something tens and hundreds, but instead of units, it's thousands. So this is the thousands place with the 0, and then the 5 is in the 10,000s place, and the 2 is in the 100,000s place. So that unit 1000 will follow us through all of the commas. So then we just have to figure out what the whole thing is. We have units, we have thousands, and then hopefully we know that millions is next. So that's millions. So then this one has got to be our billions, because that's all we got left on here. So our nearest billion is going to be rounding this number. And so we know that it's going to be 430 something billion. And now we just have to figure out what that something is. 5. We look at the number before it and we see that it's bigger than 5. So it's going to make 5 round up to 6. Another way of thinking about rounding is if I tell you I'm going to give you this much money, but I only have billion-dollar bills. I don't have any tens or hundreds or, billion-dollar bills don't exist, but we're going to pretend that they do. How many bills do you want me to give you? Should I just give you 5 or 6 billion? Or do you want your full 435 billion and something? Do you want me to round it up? You want 436 bills that are worth $1 billion each. All right, so now we've got 2 left and they have fractions, and some people don't like fractions. I'm going to start with number 5 because I feel like that one's just a little bit better. So it says, what is 2/3 of 420? And you're thinking, I don't know how to do that. Well, what is half of 420? Can you do that in your head? Okay, so 1/2 of 420, well, that means that we just divide this by 2. So 420 divided by 2 is 210. Okay, so now let's say 2/3. Well, instead of doing 2/3, I'm just going to do 1/3 because it looks a lot similar to the 1/2 that I just did. So what is 1/3 of 420? Well, this one is a little bit harder because it's not super easy to divide. We can split it up because we can say that 420 is the same thing as 300 plus 120. So what's 1/3 of 300? That one's pretty easy to do. To divide 300 into thirds, we know that it's 100. And then the other part of that would be plus something else. 120 divided into thirds. Now, if you know your division, we know that 12 divided by 3 is 4. And so if it's 120 divided by 3, it's going to be 4D. We just add that 0. So that's where we're going to get 40. And so now, without having to do 420 and do long division, I realize that 1/3 of 420 is 100 plus 40, or 140. Now, if I'm like, I don't know, does that really make sense? Let's add it up. If I do 140 3 times, if this is a third, and this is a third, and this is a third, then if we add them all up, we should get a whole, or our 420. So we're going to add them up. 4 plus 4 is 8, plus 4 more is 12. 1, 2, 3, 400. And 420 is our whole. That's what we started with. So if we divide it into 3 equal parts, we'll get 140 in each part. Okay, but we're not quite done because we're asked for 2/3 of 420. Well, I found that 1/3 of 420 was 140. So if 3 of them makes a whole, then 2 of them would make 2/3. So now I just have to add that 140 twice, and I get 280. Okay, so I didn't even teach you what I teach my algebra students, which is 2/3 of 420. Of means to multiply. So I would multiply 2/3 times 420. You can do it that way. If you know that and you want to do it that way, that's fine. But I thought of things that I already knew, and I already think that 4th and 5th graders will know, is half of something. And so if we can do a half, then we can also do a third. If we can do a third, then we can add 2 of the thirds together to get 2/3. So whether you do it in pieces like this, or whether you know that 2/3 of means to multiply 420, and then you say, well, I'm just going to put 420 over 1. I'm going to say 2 times 420 is 840 thirds. And if I want to do that, I would take 840 and I would divide by 3. And I would get that 3 goes into 8 2 times. I subtract and I get 24. 3 goes into 24 8 times. I get an even 24, and so then I add my 0. So this would be like the fast way. This is what the kids in algebra should know how to do. But doing it this way is a way of working it out. This math test is all about how you can figure it out. And did you notice, even on these 6 problems, I skipped around. I did the ones that I thought would be easier to explain first, and now I have this last one left. So when you're working this math test, this competition problem, you're going to find that you have about a minute to do each problem. Some of them are going to be really fast. That rounding one didn't take us long at all. But some of them are going to take you a little bit more time. 2/3 of 420. How am I going to figure that out? So go with the ones that are easier to figure out first, and then come back to the ones that are going to take you longer. If you see how to work it out, then do that one first. Get all the easy ones first, and then come back around to the harder ones where you're going to have to spend a little bit more time. Okay, the last one we're going to do, I'm going to write it up here. 3/8 minus 1/6. Now, if you haven't worked a lot with fractions, then this might be a little bit harder. I'm going to draw a picture. My pictures are not going to be perfect, like your books are probably a little bit more perfect, because I just can't draw perfect. So, all right, so this is 1/6. My rectangles are about the same size because they're supposed to be a whole rectangle. So this is 1/6 of a rectangle. And this one, I got to divide into 8ths. So I have 1, 2, 3/8 minus that 1/6. So if I were to like draw this one underneath that one, it would be about here. So I have 3/8 and I want to take away a little bit more than an 8 because I want to take away a 6th. If you've done fractions before, you know that when we're adding or subtracting, we have to get a common denominator. And to do that, we multiply the top and the bottom numbers by more. It's like I want to take this one that I have, divide it into 6, and I can say, I'm going to divide it again and make them 12ths. And if I do that, I have 2 12ths. So what I did with my 1/6 to get it to be equal to 2 12ths is I just multiplied everything by 2. I multiplied the 1 by 2 and I multiplied the 6 by 2. I can do it again and make it 4 over 24. I multiplied the 2 by 2 and I multiplied the 12 by 2. So I'm going to say that this is the same thing as 4 24ths. And then this 3/8 over here, I'm going to do that. I'm going to multiply by 3. So I'm going to take the 3/8 and instead of multiplying it by 2, I'm going to multiply it by 3. And you'll see why I chose to do that. 3 times 3 is 9 and 8 times 3 is 24. So if I divide each of these 8s 3 more times, then I would have 24 teeny tiny boxes and 9 of them would be colored. Now I divided this one, change my color again. These are 12ths. And so if I divided all of them again, then I would have 24ths. You're just going to have to trust me because I know that the computer screen isn't easy to see. And I have 4 of them colored. So in other words, I have 4 colored here and 9 colored here. I want to subtract 9 24ths minus 4 24ths. So I'm just going to take away 4 of these that are colored, which means I have 5 colored still. So 9 minus 4 is 5, and they are 24ths because we've divided them into 24 teeny tiny squares inside that rectangle. So this one is something that you probably learn around the end of 4th grade, maybe in 5th grade, about how to subtract fractions. But you can draw some pictures and divide them up. If you know a little bit about fractions, you can figure this one out. If you don't know about fractions yet, if you haven't learned it in your curriculum and this just seems too hard, then just skip this problem when you're doing the math contest, because there's going to be a lot of ones that you do know or that you can figure out. And drawing pictures always helps. So far, what I have taught you is how to do these problems, but also that we want to use what we know. So this one was a little bit simpler. We use this one to figure out the second one, the next one. So use what you already know. In this 2/3 of 420, I said, well, what's half of it? What's a third of it? So I started with a little bit of what I already knew to figure out more, and then go after the easy ones. If you know what place value the billions is, then do this one first. All you have to do is round the number. You don't have to do any calculations. And then draw a picture. If you want to try to figure it out, then draw a picture. So those are my hints for this week, and we'll keep practicing.